In August 2024, the James Webb Space Telescope did something it was never built to do. It turned away from the ancient, distant universe, the galaxies billions of light years away that made its name, and pointed instead at the closest sun-like star to Earth, Alpha Centauri. What it captured in that image made astronomers stop everything, a faint point of light sitting exactly where a planet should never survive. And when scientists went back to look again, it was gone. Not moved, not dimmed, gone. The explanation for why it vanished and what happened when researchers finally looked again this year might be one of the most genuinely unsettling stories in astronomy right now. For over 60 years, astronomers have quietly obsessed over one specific point in the southern sky, not because it's the brightest object out there, but because it's the closest. Alpha Centauri is a triple star system in the constellation Centaurus, and its two main stars, Alpha Centauri A and Alpha Centauri B, sit just over 4 light years from our solar system, according to NASA's own mission reporting. In cosmic terms, that's not a distance at all. That's the house next door. And for decades, we've been staring at that house, wondering one simple thing. Is anyone home? Here's what most casual space coverage genuinely gets wrong about this story. Despite being our closest neighbor, despite astronomers having confirmed nearly 6,000 exoplanets across the galaxy by now, Alpha Centauri A, the star that's almost a perfect twin of our own sun in size and age, and the third brightest star in Earth's night sky, remained a locked vault for decades. Proxima. Centauri, the small red dwarf in the same system, already has 3 confirmed planets. But every serious attempt to find a world around Alpha Centauri A specifically had ended in frustration, false alarms, or silence, according to Stewart Observatory's own reporting on the ART research. The problem was never distance, it was light. Alpha Centauri A and B are so bright, so close together in the sky, that even the most powerful ground-based instruments drown in their glare. Researchers involved in this project have compared the challenge to trying to spot a firefly hovering next to a lighthouse from hundreds of kilometers away, while the lighthouse itself is moving. For generations of astronomers, this was considered one of the most brutal observational challenges in the entire field. Aniket Sanghi, a Caltech PhD student and co-author on the eventual discovery papers, told Scientific American he specifically sought out Alpha Centauri A precisely because it was one of the most difficult targets he could find to work on. Then came the instrument that finally cracked it open, the James Webb Space Telescope, the largest, most powerful space observatory ever launched, was designed and optimized to find the most distant galaxies in the universe, objects billions of light years away at the very edge of observable time. Pointing it at a star 4 light years from Earth was, in a real sense, using it for something it was never primarily built to do. The operations team had to design a custom observing sequence specifically for this one target, according to reporting from Astronomy magazine, with no standard playbook to follow. In August 2024, they made the attempt. Webb's mid-infrared instrument, MIRI, deployed a chronographic mask, a device that physically blocks the blinding light of a star, directly over Alpha Centauri A. Even that wasn't enough on its own. Light bent around the edges of the mask, creating ripple patterns across the image. The telescope's own mirrors and support structures introduced their own interference, and Alpha Centauri B, the second star in the pair, poured its own contaminating glow into the frame. So the research team built a digital model of the contaminating light from both stars and subtracted it, layer by layer, according to Astronomy magazine's detailed breakdown of the process, essentially digitally cleaning the image until whatever was actually there could be seen clearly. What emerged was a single point of light, more than 10,000 times fainter than Alpha Centauri A itself, sitting at a separation of roughly 2 astronomical units from the star, according to the peer-reviewed paper published in the Astrophysical Journal Letters. The team labeled it S1. And if S1 was real, it wouldn't just be another entry in an exoplanet catalog. It would be the closest planet to its host star ever directly imaged in human history, and the nearest imaged world to Earth itself. But before anyone could get excited, the team had to answer a genuinely difficult question. What if it wasn't a planet at all? A faint smudge in a heavily processed image can be almost anything. A background galaxy photo-bombing the frame, a passing asteroid, or an artifact created by the detector itself. Astronomy has a long history of these phantom detections, quietly destroying otherwise promising research careers. So the team, according to the published methodology in their own papers, ran round after round of deliberate tests, specifically designed to rule out S1, to prove it was a glitch, a galaxy, anything ordinary. One by one, according to the team's own published findings, every mundane explanation failed to account for what they were seeing. That left only one real path forward. Go back and look again. If S1 was a genuine planet, it should still be there, moving predictably along its orbit. In February 2025, using valuable director's discretionary telescope time, the team turned Webb back toward Alpha Centauri A. They found nothing. The point of light had vanished from the exact region of space where physics said a planet should be. Before we get into what that disappearance actually means and why a second and third failed observation didn't end this story the way you'd expect, I want to know. If you were on this research team and your history-making discovery vanished the moment you tried to confirm it, would you have kept looking or moved on? Drop your answer below and subscribe now, because Section 2 is where this mystery gets genuinely stranger. The team didn't panic after that first failed follow-up in February 2025. Orbits are complicated, and a single missed observation isn't necessarily the end of a discovery. So in April 2025, they looked a third time. Nothing again. Now stop and actually sit with what that means. The most powerful telescope ever built had captured an object next to our nearest sun-like star. An object that passed every single test the team could throw at it for being real. And then that object simply stopped appearing. 2 follow-up observations, 2 empty images. In most corners of astronomy, that's exactly where a discovery quietly dies, filed away as an unconfirmed mirage and forgotten within a year. But this wasn't the first time something had been spotted near Alpha Centauri A, and that detail is precisely what turned it. This from a curiosity into a genuine mystery worth solving. Rewind to 2019, years before Webb ever pointed anywhere near this system. A team led by astronomer Kevin Wagner, using the European Southern Observatory's Very Large Telescope in Chile, detected a candidate object near Alpha Centauri A, labeled C1, first reported in a 2021 paper published in Nature Communications, according to Wikipedia's documented summary of the finding. It appeared at roughly 1 astronomical unit from the star, but the observation window was too short to prove conclusively. It was a planet, and skeptics argued at the time it could just as easily be a cloud of dust or an instrumental artifact. The detection faded into scientific limbo for years, unconfirmed and largely forgotten by everyone outside a small circle of researchers who kept quietly tracking it. Until researchers laid that 2019 sighting next to the 2024 Webb detection, and a genuinely compelling pattern emerged. In 2019, an object of a certain brightness appeared on one side of the star. In 2024, an object of comparable brightness appeared on the opposite side. Wagner, now an assistant research professor at Stewart Observatory, explained the significance directly in the University of Arizona's own reporting on the discovery. When all you have is a dot of light next to a star, you may or may not be looking at an actual planet. But when you see a dot of the same brightness several years later on the opposite side of the star, the story becomes much more compelling. 2 different telescopes on 2 different continents, 5 years apart, showing a comparable signature. That's not random noise. That pattern looks like motion. So the research team, which by this point included Caltech's Aniket Sanghi and Charles Bachman, executive director of NASA's Exoplanet Science Institute, built simulations covering millions of possible orbits to test a single question. Could one object actually explain everything they'd seen? The 2019 sighting, the 2024 detection, and the 2 subsequent disappearances? They factored in the original VLT observation, all 3 rounds of Webb data, and 1 genuinely difficult constraint, according to the published methodology. Any viable orbit had to remain gravitationally stable in the presence of Alpha Centauri B, the second star in this tight binary pair. In a system like this, an unstable planet doesn't just wobble unpredictably, it eventually gets flung out of the system entirely by the second star's gravity. The result, based on the peer-reviewed findings, was a single plausible world. A gas giant roughly the mass of Saturn, looping around Alpha Centauri A on an orbit lasting somewhere between 2 and 3 years, according to the published paper's own orbital modeling, on a stretched elliptical path rather than anything resembling a neat circle, an eccentric orbit with roughly a 0.4 eccentricity value that swings the planet dramatically closer to and farther from its star throughout each orbit. And here's the detail that makes the entire mystery collapse into place logically. In a meaningful share of the simulated orbits, the planet would have swung close enough to the star during February into April 2025 that Webb's coronagraph physically couldn't have distinguished it from the star's own glare. The 2019 and 2024 images caught the planet during the portion of its orbit where it was actually visible beside its star. The 2025 attempts were, according to Wagner's own explanation, simply unlucky timing, catching the planet while it had slipped in front of or behind its sun from Webb's vantage point. In August 2025, the findings were formally accepted for publication as 2 companion papers in the Astrophysical Journal Letters, one of the most respected peer-reviewed journals in the field. Wagner, who'd been chasing this specific ghost since 2019, called it one of the most exciting results in astronomy of the decade. according to Stewart Observatory's own reporting. This wasn't fringe speculation dressed up for headlines. This was a team spanning Caltech, NASA's Jet Propulsion Laboratory, and the University of Arizona putting genuine institutional reputation behind a carefully hedged but genuinely significant claim. Now here's the part of this story that most surface-level coverage tends to skip past entirely, and it's exactly where the word disturbing in this video's title actually earns its place. This candidate planet, if it's real, sits inside Alpha Centauri A's habitable zone, the specific region around a star where surface temperatures could theoretically allow liquid water to exist. For decades, that phrase has carried something close to humanity's deepest hope about our nearest neighboring star system. That somewhere in that narrow band of warmth around the star, most similar to our own sun, a second Earth might genuinely be waiting. Every serious interstellar mission concept ever sketched out, every proposal to eventually send probes toward Alpha Centauri, has been built at least partly on that specific hope. This discovery, if it holds up, may complicate that hope significantly, because the object sitting inside that habitable zone isn't a rocky world at all. Based on the published photometry and orbital modeling, its mass sits somewhere between 90 and 150 times the mass of Earth, with a radius comparable to Jupiter's, according to the peer-reviewed data. That's not a planet with a surface to stand on. That's a crushing sphere of gas, with no oceans, no continents, and nothing resembling solid ground anywhere within it. Before we get into exactly why a gas giant sitting in that specific location might mean something much bigger for the entire habitable zone around our nearest solar twin, and why some astronomers are calling this planet's mere existence a genuine challenge to how we think planets form at all, I want your take. Does knowing our closest, sun-like star's habitable zone might already be occupied by an unlivable gas giant change? How you think about humanity's long-term prospects of ever reaching a second Earth nearby? Drop your answer below and subscribe now, because Section 3 is where this story gets into genuinely disturbing territory. Let's sit with what a gas giant occupying Alpha Centauri A's habitable zone actually means, because the implications go well beyond just no second Earth here. According to the research team's own published analysis, the planet's highly elliptical orbit doesn't just occupy the habitable zone briefly in passing. It sweeps through most of it repeatedly, every 2 to 3 years, on that eccentric path researchers modeled. Aniket Sanghi described the consequence directly, and it's genuinely the kind of image that sticks with you. A planet like this would make it unlikely that smaller rocky planets could survive there at all, its gravity clearing out anything Earth-like from that band of warmth the way a bowling ball clears its pins. If that assessment holds up under further scrutiny, it means the habitable zone of the closest sun-like star to Earth isn't a peaceful, empty region patiently waiting to be discovered and settled someday. It's a demolition zone, a stretch of space where any rocky, Earth-like world that might once have formed there was either destroyed outright, gravitationally devoured, or flung into interstellar darkness sometime over the billions of years this system has existed. The house next door, in other words, isn't simply empty. If this candidate planet is confirmed, it's occupied by something whose orbit appears specifically positioned to ensure nothing gentler could ever coexist there. Here's the second disturbing layer to this story, and for the scientists actually studying planet formation, it might genuinely be the bigger one. This planet, according to everything we understand about how planetary systems form, probably shouldn't exist at all, at least not where it's sitting. Alpha Centauri A and B are two closely separated stars locked in a tight mutual orbit, a genuinely chaotic gravitational environment where two suns are constantly tugging at everything caught between them. Our best existing theories of planet formation generally hold that building, and then keeping a massive gas giant stable in that kind of environment, should be extraordinarily difficult. The gravitational interference from a nearby second star is exactly the kind of force that should shred a forming planetary disk before a giant planet can fully coalesce or destabilize any giant that manages to form anyway. And yet, according to the paper's own author, Sanghi told NASA directly that the planet's very existence in a system of two closely separated stars would challenge our understanding of how planets form, survive, and evolve in chaotic environments. That's a genuinely significant statement coming from a peer-reviewed publication, not hype-driven speculation. If this candidate is eventually confirmed through follow-up observation, it doesn't just add one more entry to the exoplanet catalog. It forces a real, substantive re-examination of a specific piece of planetary formation theory that astronomers have relied on for decades when predicting where giant planets can and can't reasonably exist in binary star systems. Now, let's be genuinely intellectually honest here, because this is exactly where a responsible breakdown separates itself from pure hype. The scientific community has explicitly not stamped this discovery as confirmed. The research team themselves, in their own published papers, acknowledge directly that with only a single, robust web sighting, The candidate cannot be unambiguously confirmed as a genuine planet without additional observations actually tracking its motion over time. Eric Agol, an astrophysicist not directly involved in the research, praised the underlying work but specifically cautioned, in comments reported by Scientific American, that it remains too early to definitively call this object a planet. Elizabeth Matthews, an exoplanet-focused astrophysicist at the Max Planck Institute for Astronomy, offered a similarly careful framing to Scientific American. If it's real, it's amazing, a sentence that quietly carries a genuine unresolved conditional inside it. Other researchers involved, including ESA astronomer collaborators cited in the coverage, have noted that even a confirmed non-detection in future observations would still carry real scientific value, because it would demonstrate just how far Webb's instruments can genuinely be pushed beyond their originally intended design purpose. The evidence taken as a whole is genuinely strong. The orbital modeling fits the observed data cleanly. The independent 2019 and 2024 detections align in exactly the way you'd expect from a single real object, rather than two unrelated artifacts. But in serious science, almost certainly is meaningfully different from certainly. And that razor-thin gap between candidate and confirmed is precisely where this entire story currently hangs, right up to this moment. Here's what makes this particular mystery genuinely different from most unresolved astronomical questions you'll hear about. This one has an actual date attached to its resolution, and that date isn't some distant future milestone. Based on the team's own orbital calculations, the planet candidate is believed to complete a full orbit roughly every 2 to 3 years, which means researchers have already calculated the next specific window when it should swing back into a position where Webb could observe it directly, August 2026. As of this month, that's not a distant hypothetical future event. That's now, or within the very next few weeks of whenever you're watching this. The research team has been actively pushing to secure additional telescope time on Webb specifically to make that observation. And Wagner has stated plainly, in reporting from Scientific American and NASA's own release, that this specific window represents the best opportunity to confirm the planet's identity beyond reasonable doubt. Somewhere in the coming weeks, the most powerful telescope humanity has ever built may turn back toward the nearest sun-like star to our own. And this time, unlike the two failed follow-ups in early 2025, the entire research team knows precisely where to look and precisely what should be sitting there if their orbital model is correct. If the dot reappears exactly where the model predicts, the case effectively closes, and a genuinely new world enters the history books as the closest directly imaged planet to its star, orbiting the closest sun-like star to Earth itself. And if it isn't there again, we're left with something arguably even stranger than a simple confirmed discovery. 2 separate telescopes, 5 years apart, both independently detecting an object that survived. Every test thrown at it, an object that behaves exactly like a planet in every measurable way, yet somehow continues to evade being definitively caught. Before we bring this all together in the final section and talk about what either outcome actually means going forward, for this system specifically, and for exoplanet science more broadly, tell me, given that the resolution to this exact mystery could genuinely arrive within weeks of you watching this, are you rooting for confirmation, or do you think the more scientifically interesting outcome would actually be another disappearance? Drop your answer below and subscribe now, because the final section brings together everything this discovery could mean and what's coming right behind it to help settle the question for good. So let's bring this entire story together, because whichever way August 2026 resolves this specific question, this discovery has already changed something real about how astronomers think about our nearest stellar neighbor. And it's worth being honest about exactly what that changed and what remains genuinely uncertain. Here's the confirmed, settled part of this story. In August 2024, using a custom-built observing sequence never before attempted on this specific target, the James Webb Space Telescope's mid-infrared instrument captured a real, statistically robust point source next to Alpha Centauri A, a detection that survived rigorous testing designed specifically to rule out background objects, foreground contaminants, and instrumental artifacts. That detection, labeled S1, aligned closely enough with a separate 2019 detection from ground-based telescopes in Chile, labeled C1, that a team spanning Caltech, NASA's Jet Propulsion Laboratory, and the University of Arizona built a full orbital model treating both as the same object, a model that fits the observed data cleanly and explains why 2 subsequent 2025 observations came up empty. That work was accepted for publication in the Astrophysical Journal Letters in August 2025, one of astronomy's most rigorously peer-reviewed venues, not a preprint circulating on social media. That part of the story isn't hype. It's documented, published science. Here's what remains genuinely, honestly unconfirmed and deserves equal weight in how you think about this. A single robust detection, however carefully vetted, is not the same thing as a confirmed planet with a fully verified orbit. The research team has said so themselves explicitly in their own published work. Independent astronomers not involved in the discovery have echoed that caution publicly, even while acknowledging the underlying research is genuinely serious and exciting. The gap between extremely compelling candidate and confirmed exoplanet is real, and it's a gap that only additional direct observation can actually close. That's exactly why August 2026, right around when you're likely watching this, matters so much. The team's own orbital modeling puts the planet back into an observable position relative to its star during this specific window, and researchers have been actively working to secure the Webb telescope time needed to look again. If they get that time and the detection reappears exactly where the model predicts, this stops being a candidate and becomes one of the most significant confirmed exoplanet discoveries in the telescope's history, the closest ever directly imaged planet to its host star and the nearest imaged world to Earth itself. If it doesn't reappear, the mystery doesn't necessarily die, it just deepens. Because two independent telescopes on two different continents will have each detected something that passed every test for being real 5 years apart, and neither confirmed nor definitively ruled out. And Webb won't be working alone on this question for much longer. NASA's Nancy Grace Roman Space Telescope, scheduled to launch by May 2027 and potentially as early as fall 2026, carries dedicated hardware specifically designed to search for hidden worlds around binary star systems, exactly like Alpha Centauri, according to NASA's own mission reporting. Roman's coronagraph was purpose-built with a level of sophistication specifically aimed at teasing out large exoplanets around nearby stars, and its visible light observations would eventually combine with Webb's infrared data to reveal far more about this candidate's actual size, composition, and reflectivity than either telescope could establish alone, transforming a single dot of light into a genuinely characterized world. Bateman himself described what this candidate would become if fully confirmed: a touchstone object for the entire field of exoplanet science, studied repeatedly by observatory after observatory for decades to come, precisely because it sits closer to Earth than any other comparable discovery ever has. Here's the honest, complete DI picture to leave you with. We now have strong, peer-reviewed evidence pointing toward a genuine giant planet orbiting our nearest solar twin, sitting in a location our current planet formation theories say it probably shouldn't be able to survive. If confirmed, its presence would mean the habitable zone of the star most similar to our own sun, the one place in our stellar neighborhood most people have quietly hoped might harbor a second Earth someday, is far more likely to be a chaotic, cleared-out region than a peaceful cradle for rocky worlds. That's a genuinely significant, if sobering, recalibration of decades of quiet hope surrounding this specific star system. And it comes with a real, dated resolution already on the calendar, not some vague promise of someday we'll know more. We know approximately when the planet should reappear if the orbital model holds. We know exactly where the telescope needs to look. The trap, in a sense, is already set, and the clock is genuinely running as you watch this. But the deeper questions this discovery raises extend well past whether this one specific candidate gets confirmed in the coming weeks. If a massive planet really did survive the gravitational chaos of a tight binary star system, an environment our models say should have made that survival extraordinarily unlikely, what does that mean for how many other genuinely improbable worlds we've quietly dismissed or overlooked across the wider galaxy, in systems astronomers assumed were too chaotic to host anything substantial at all? For 60 years, we assumed our nearest stellar neighbor was quiet because it was likely empty. This discovery, whether it's ultimately confirmed this August or the mystery deepens instead, suggests a different possibility entirely. That we simply weren't capable of seeing clearly enough what was actually there all along, hidden not by distance, but by the overwhelming glare of the very stars we were trying to study. I want to hear where you land on this. Given everything we've walked through, the two independent detections, the orbital model that explains the disappearances, and the genuinely rigorous scientific caution still surrounding it, do you think Webb confirms this planet when it looks again this August? Or do you think this becomes one of astronomy's great unresolved mysteries instead? Drop your prediction in the comments. I read every single one. And if this breakdown gave you a clearer, more complete picture of what's actually happening at our nearest star system instead of just the sensational headline version, do me a favor. Hit subscribe, tap the notification bell, and share this with someone who'd want to know we might already know exactly when we'll find out the truth. Thanks for watching, and I'll see you in the next one.